So, hi everybody. It's Monday, I think. Yeah, it is Monday. What a crazy time of the year. I hope you're all doing okay. I know that, we've only got like a couple of weeks to go, and I'm sure you're all extremely busy finishing assignments and so on. So, my hands up to all of you and wishing you all the best. So I'll just gonna and thank you for your comments on Dr. Ryan's lecture last week. Yeah, I think we're very fortunate to have had her speak to us about her knowledge systems, indigenous knowledge systems, and how they are so crucial to our steps forward with dealing with climate change. And yeah, I really appreciate your feedback. Um, so today we're going to talk about nature-based solutions to climate change. Or what did I call it? Yeah, nature-based solutions to climate change. So these are the learning objectives for today. To understand what the concepts of urgency and agency are with respect to climate change, understand what solutions are being prioritized at the global level. And of course, they're prioritized at the global level, but the action actually happens at the local level, which is interesting. We need both. We need governance at the top and we need action at the bottom. And the trick is to bring them together into something that works. I want to go over what the nature-based solutions that are identified as priorities in Canada and sort of compare them with what the United Nations is saying, and what my own thoughts are. And then I'm going to go into some of the current research that we're doing, and many people are doing research on this, but I think the research program in my group is an example, and it's a good example of what people are looking at. There are solutions. I think that's the thing I want you to know is that there are solutions, and it's not so much what we need to do. That's the mystery. It's that the mystery is that this is becoming it's a social problem. It's like, how do we mobilize people and governments to do what we need to do? And then I'm going to end with 5 actions that I think can be taken and where I think need to be taken. And this reflects what's being said in the United Nations as well as for Canada. What are these actions and how do we do them to mitigate climate change? So I hope this is a hopeful lecture, but there's also things, I have to sort of go through some of the realities so that we understand what we have to do. Okay, so I'm gonna start again with Robin Wall Kimmerer and the honorable harvest because I mean this concept underpins really the way of seeing the world, the way of knowing the world, and the way of doing what we need to do. It's just sort of like like a philosophy, but it is essential. I mean, we can do a lot of things, but if we don't have the right intentions and the right way of looking at the world, we can miss the boat, and we really can't afford to. Um, so just to come back to what Robin has said and what Indigenous people all over the world say in general, that they're the principles that guide the way of being that govern the exchange of life for life with reciprocity, which means the back and forth, the give and take, never taking too much, the gratitude for the gifts of the Creator and all that we have here, and the sustainability in interactions with the natural world. This is about relationships between us and Mother Earth, us and the forests, us as people and how we see ourselves in the natural world and how we relate to it. These are all so essential. And she has these very basic principles of the honorable harvest that if we applied these in forestry, in agriculture, in fish harvesting, we would, we will solve these problems and we wouldn't have gotten into the problem in the first place. But here we are. But these principles to guide us, to ask for permission when we do a harvest. That permission is seeking permission for the people who live on the land. So if it's Indigenous territories and the Crown or the corporate world wants to do something, they need to ask permission, and it has to be done following the United Nations uh, Declaration on the Rights of Indigenous People principles, free, prior, and informed consent, first and foremost. And then also asking permission of the land. And if the land is saying no, that, there's not enough here right now at this time, then you walk away and you go harvest somewhere else, or you just wait. Taking only what you need, not too much, just what's needed, not excessive harvests. And think of it as I go through this, think of forestry, what we do in forestry. Never taking the first or the last. This really is about, making sure there's enough for the system to recover, to be resilient, and for the next generations, the next 7 generations, keeping that always in mind. Am I leaving enough here for my great, great, great grandchildren? To harvest respectfully. So that means, if you're harvesting a forest, leaving the elders, some of the elders behind so that they can bring up the next forest, not taking all of the trees like you do in a clear cut. Always giving back and, showing gratitude, giving offerings for the regeneration of the forest, to help it return to what it was, before the harvest, and always to be sustaining the source of life, the water, the air, the sun, and so on. And I've added on here from the last slide, because I went through this last time, but, we talk about natural laws. And I just want to remind people that, we have our human laws, and these human laws are meant to, sort of guide us or to set forward rules that cannot be broken in a civil society. But there's also natural laws. And sometimes we forget what these natural laws are. But natural laws are just the natural energy that flows in everything, in the spirit of all beings in the forest. Okay, so when I say that, think about that. The spirit, that's the energy of the forest. And often when we do forestry, corporate forestry especially, there is really no thinking of the spirit of the beings in the forest. That is in the trees, the water, the air, the energy. And importantly, that this spirit is sacred. It is not to be misused or abused. So that, if anything that you take away from this class, is to have this understanding of what are the principles and practices, what are the natural laws that must be respected as we go forward in solving climate change. We need to really be thinking of these philosophies. I wanted to just, put this in here that Anishinaabe people, who are an Indigenous people of Canada, of Turtle Island, have 7 grandfather teachings. These are also laws and natural laws, just expressed in a different way. They are that we govern ourselves with respect, with love for each other and Mother Earth, in truth, always in truth, in factual evidence, in bravery and courage, with wisdom, with generosity and humility. These are actually, show up in all of our, even in our laws today that govern Canada, they show up. But we sometimes, they become so forgotten in their essence, I would say, that we become adherents to the written word and we forget the spirit of the law. Yeah, I keep these in mind. Write them down and put them in your back pocket, and help them govern you as you walk through this world. Okay, so let's talk about what are these natural solutions to climate change, and I again borrow or honor what the United Nations has put forward, because it is all nations coming together in respect under the natural laws, and coming up with the best solutions they see, as we see as people moving forward. These are, of course, convened by hundreds and hundreds of people, Indigenous people from all over the world, saying this is what we need to do, and it fits. So let's look at these. So this figure, which is again, the International Panel on Climate Change, which is a United Nations body, has really done a great job of trying to convey to all of us, the urgency of the matter before us and what we do, and the timing of when we need to do it. And along the x-axis in this figure, we have time and the present world. And it says IPCC AR6. This is when 2023, when the report number 6 came out. And so they're saying, okay, here we are. We're at this point in time, and uh, we're kind of have options in front of us. And there are options that lead to a healthy future and options that lead to a much more scary future. Along the y-axis, it says emissions reductions, adaptation, sustainable development, climate resilient development. So as you go up the y-axis, it gets better, it's greener, and as you go down the y-axis, it's a more climate dangerous future. And so then it says, okay, there's these different pathways. One pathway is to limit warming to below 1.5 degrees Celsius. So we're hovering at that increase already right now. And it's saying if we want to stay below this, we need to act now. We can't wait. And and right now, we're not, our actions are, they're starting to have some effects at the global scale. We are seeing, as I mentioned, Michael Mann, as the climate scientist, is measuring a flattening of emissions overall globally. But we're still not out of the woods, obviously. We still have a lot to do, and that could change at any time with, as with for all kinds of reasons. But it does show that we can act as global citizens, as a whole. We can act, and we are acting, and we need to keep doing that. And then these other options, the red one, for example, is where we don't want to go. And this is where we're exceeding 1.5 degrees. And in fact, it's kind of like the worst case scenario of the projections, which are for a 4 to 5 degree increase by 2100. So how do we get on the green path? It says these are the conditions that enable inclusive governance. That means not authoritarian governance, but democratic governance that includes all people, as many people making decisions as possible, diverse knowledges and values, including community-based knowledge, indigenous knowledge, scientific knowledge, good philosophies and values. Innovative finance and innovation. Right now, I would say that, financially, a lot of money is stuck in a very small percentage of people at the upper wealth echelons, and most people have very little. In fact, there's a lot of inherited wealth, a lot of wealth that is basically being hoarded and not being put into action. And then there's all of these enablers in political environment that keeps it there. But we need to move that money so that it gets down into the people that are actually doing work on the ground. So that is going to require new financial models and innovation. So people that are actually, have their hands in the soil and are building back these ecosystems. We need to be integrated across sectors and timescales. The industrial, forestry, gas, oil and gas, all these public health, all need to be integrated. We need good ecosystem stewardship, which I'll be going over a bit later. Like, what do we do at the ecosystem level? We need synergies between climate action and development action. There's sustainable development means that you do it so it's sustainable in the future. So these need to be brought into alignment. And we need behavioral changes. Okay, so if we do all this, we will have lower emissions. We'll have systems that transition to sustainable systems. We'll have low climate risk. We'll have social equity and social justice, and we'll achieve social development goals that have been articulated at various scales and various levels of governance already. And we just need to look at them and make sure we're enabling them. The conditions that constrain are keeping people in poverty, keeping things unequal, in social injustice, setting up economic barriers, institutional barriers, and so on. Siloing our responses. It doesn't do us any good if we're, fixing stream beds in lower parts of a watershed while we're clear cutting the headwaters, right? That's a siloed response. They need to be integrated so that all actions are adaptive and helpful. We need, so we can have that. We need finance flowing, like I talked about. We need to understand that there are and we need to avoid these trade-offs. So anyway, if we continue on this constraining pathway, we're going to have high emissions, entrenched systems, limits, increased risks, ecosystem degradation, and so on. So I vote for the green path. And so that's what we're going to talk about today. Let's look at these sustainable development goals. And the United Nations has articulated these well. I know the United Nations is a governing body that has not always succeeded in actuating its goals, and that's our fault, right? As citizens of the world, we need to protect these institutions and empower them so that they can meet these goals. Sustainable development is intended to meet the needs of the present without compromising the ability of future generations to meet their own needs. Do you hear echoing in that the 7 generations principles of the Anishinaabe people? I think so, right? It's all reflected in there. This picture you've probably seen all over the place that UN tries to articulate these in a very easy, understandable way. No poverty, no hunger, good health and well-being, quality education, gender equality, clean water, affordable and clean energy, decent work, industry, innovation, infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, protecting species diversity in the water and on the land, peace and justice, and strong institutions, including the United Nations Partnership for the Goals. And I think we need to support our institutions, big and small, so that we can actually work, because they're for us, they're for the people. And in spite of their faults, we need to put our energy into them so that we can achieve these goals. Canada has adopted the goals of the United Nations, and I just put this down here. They've got their own specific goals, and the Auditors General's Act states that sustainable development is a continually evolving concept. It's not set in stone. It's going to keep changing. But it does look at the integration of the environment and economy, protecting health of Canadians, ecosystems, meeting our international obligations to the Council of Parties, for example, and the Paris Agreement, promoting equity, integrating, preventing pollution, respecting the nature and needs for future generations. It's all right there. We have it in our, at our highest levels. So now what I want to do, how do we achieve these, and how do we, mitigate, what are the actual actions on the ground that we need to do that's going to reduce our risks and increase, our wealth and power and health in the future. So the United Nations, and and I'll go through most of these, has come up with, and categorized and prioritized the things that we need to do in order to, draw down carbon dioxide by 2030, to not exceed 1.5, to hold the line where we're at right now and maybe even reduce it. And so here it's got, what are the options? And then, and you can study this, and it categorizes what the options are according to energy supply, what we do on the land, water and food. This is mostly around agriculture. And what do we do? Agriculture and forestry and ecosystems. What do we do in infrastructure with buildings and, built systems, for example, health and society and economics. So I'm not going to go through this in every detail, but what this does is it actually shows what are the most effective things that we can do. And it categorizes these as according to the cost of doing this, and how difficult it is. So blue would be that it's a low cost, and red is it's a higher cost, but still highly effective. So red means that, it may be expensive, but it's also a high impact action. So the first thing it's saying about energy supply is, is to to switch to renewable energies. Those are the most impactful things that we can do for reducing emissions by 2030. Switching from fossil fuels to solar and wind, to reduce methane emissions from coal, oil, and gas, to create bioelectricity. So now this is something that is a big topic on itself, and Rachel Holt later in the term will talk about this. There are pros and cons to this, and you see it's low on the list. So that means like using biological systems to create electricity and energy. There's pros and cons that we can talk about later. Using geothermal and hydropower, nuclear power, which, you know, it's low on the list as well, but it's one of the many tools. And then it's got in here fossil fuel capture and storage. This is an engineered solution. And I have to say that everything I've looked at is that there is really no engineered solution that really does much so far in carbon capture. I know that the big oil and gas companies are investing a lot of research into this, but so far nothing comes even close to what our natural ecosystems do. So if you're hoping for this, or if anybody's hoping for this, it's not really going to solve our problems. But so in switching to renewable energy is a huge solution, and that's the first thing that needs to be done. The second, land, water, and food. So the very first thing, which all my research and people's research bear out on this, is to reduce the conversion of natural ecosystems to other kinds of ecosystems. This includes, which I'm going to go into later, clear cutting our forests. Right? We should not be doing that in this day and age. It doesn't mean we don't tend our forests or we don't do some harvesting, but we don't clear cut forests. So because that's a conversion to a planted forest, that's converting it from a natural ecosystem to a human-made system. And so that is really high on the list of the first thing that we can do. That should be easy for us to do. Then to increase carbon sequestration in agriculture. Okay, so that means like growing where we are having managed systems to grow sustainable crops and making sure that they have high ability to sequester carbon dioxide and other greenhouse gases and also be productive. Remember when I said back in previous lectures that carbon sequestration is most strongly correlated or very strongly correlated with biodiversity. Well, maintaining biodiversity then goes along with this. So in agriculture, that means like agroforestry, for example, where you grow many crops together. And Indigenous people have been doing that forever. And, and we know how to do this. Third on the list is restoring ecosystems. So yeah, and then that's a lot of work to restore damaged ecosystems. We have a lot of these, but this is the work where we can really pull up our sleeves and we can really increase carbon sinks on the land and increase biodiversity on the land and the oceans by doing the good work. We do know how to do a lot of this. Improved forest management. Okay, so that's further down on the list than restoration, but really, to me, it does kind of go, yeah, it is an important factor. It means like instead of clear cutting, what else do we do in forests if we're thinking about British Columbia? Okay, and you can see like when you look at overall at where the big gains are, it's in converting to renewable energy, not converting our natural ecosystems, doing a better job of protecting biodiversity so we have big carbon sequestration capacity. And then all these other things down below, like making more efficient buildings, more efficient vehicles, electric vehicles, well, those are all important too, but those aren't the heavy hitters, right? It's what we do on the land and how we use energy that are the heavy hitters that are going to get us the most gain. So not to ignore these other things, but just to put it in context. Okay, so polling question. What does the IPCC understand as the best land-based mitigation strategy? Okay, so here it is. It's reducing conversion of natural ecosystems.
Start. Done. It's perfect.
Great. Good. All right. keep that in your back pocket too, along with the honorable harvest principles. Okay, so let's talk specifically about forests. There is so much we can do in forests, and I've shown you this figure before, but just to emphasize this, that globally, what scientists estimate is that carbon storage in forests, and this figure with global figure shows where forests are. It's markedly under the natural potential, with a total deficit of 25 to 50% in areas with a, really globally. 25 to 50%. So that's a lot. That means that our ecosystems are underperforming by 25 to 50%. So, and it's setting aside, cities and so on. It says low human footprint. So setting aside cities and so on, where we have a concentration of people, the rest of the land base could use our help. And if we were to fill this 25 to 50% deficit, we could actually, reduce climate impacts by a third. That's what the estimate is. So, it tells us we need to get to work. How do we do that? So they're saying, first of all, 61% can occur in existing forests. And it's the simple thing of just allowing forests to grow naturally and grow out to their great ages. Scientists call this proforestation. It just means don't harvest the forest before it's time. And this isn't what we're doing in forestry. What we're doing in forestry is we're taking forests that are, naturally live for 200, 500, 1,000, 5,000 years and putting them on a 40 to 100-year rotations. We're cutting them at a very rapid pace, and that's depleting carbon stocks and biodiversity at a very rapid pace. So the simple thing is just let these forests grow to their natural potential. It's like letting a human being live as long as they naturally should live, right? It's not a difficult concept, but it's not what we're doing. So we need to do that. And then 31% of that recapturing of that, that deficit is to restore or reforest the areas that have been deforested or that have been fragmented and degraded in some way. Okay, so a third then is, us getting onto the land and restoring these places. This figure on the right that says D, it's just saying that the potential to fill these deficits have differences across the latitudinal gradient with very high potential in tropical areas, and it diminishes as you go north, according to this paper. However, I think that, we need to recognize that we need this work everywhere. Yes, the tropical forests are the biggest carbon sinks in the world, but it doesn't mean that we shouldn't be working on all the other ecosystems too. We need to be doing that. Well, that's really hopeful, isn't it? So to me, it's like, okay, we can solve this. We can do it by looking after the land. So I have a polling question here. And the polling question, let's see, it says, how much of the carbon deficit in forests can be filled with proforestation?
Done. Only 50% choose D, and there's like 30% choose B.
Okay, so it's 61% is the answer. So going back to the previous slide, 61% in existing forests ought to be allowed to recover naturally, and that is called proforestation. So it's 61%. Okay, that's a lot, right? It's letting forests do their thing on their own. It doesn't mean that we're not part of that solution. Like we need to be in there tending forests where they're needed. People have always been part of forests, but it means not cutting them down too early and letting them grow to their great ages. Okay, that's a simple solution. So in Canada, we've had various discussions and papers written about what's called nature-based solutions. And this term is being used all over the world too, and it fits in with all these, IPCC solutions I just went through. But there's some differences, and Canada's put its own little flavor on it. So I want to go through that. These are just actions to protect, sustainably manage, and restore natural or modified ecosystems that address the social challenges effectively, adaptively, while providing for human well-being and biodiversity. It doesn't say next generations in here, does it? But it really should. And actually, nature-based solutions in Canada have been criticized because it does neglect, in a way, to acknowledge and encompass the honorable harvest and the Anishinaabe principles, for example, not specifically those, but the Indigenous principles. And so this needs to be worked on somewhat. It needs to be inclusive and more expansive, but really, it is, I think that the flavor is still there. It just needs a little bit more work. But so this is a paper written by Ronnie Drever, who actually was a postdoc at UBC for a short period of time. He's in Ottawa now, I believe. And he's just going through, in Canada, what are the priorities for mitigating climate change? And he's got agriculture, wetlands, grasslands, and forests. And I just want to point out a few things here. One is that avoided conversions figures very high for them in peatlands and in grasslands. And it's interesting that they've got avoided forest conversions as secondary to improve forest management for forests. And this is where I disagree with them, and it disagrees with the UN as well, that the best thing that we can do is avoid conversion of forests. So they've somehow got this a little bit backwards. However, at least they have it in there. And restoration, they're showing very low potential for that, which also disagrees with some of the other papers. So I think that, obviously there's needs to be some work there, but at least it registers here. So what I would, if I were to reorient to this, I would have avoided conversions as much higher. I would have improved forest management as secondary and restoration as tertiary. They've got urban forestry cover, which is interesting. From a human perspective, of course, that's very important, but from an overall climate change mitigation perspective, it's less important because it's such a small area. Okay, overall, it's talking, Drever is saying, what are the most important actions that we can take? They sort of prioritizing agriculture, wetlands, and grasslands over forests, which is also interesting, the size of the bars. But, forests actually cover, as I've mentioned before, the majority of Canada, other than the prairies. And so therefore they ought to be a very high priority. Okay, so I've got a polling question here. What does Drever consider the best nature-based solution in Canada? So I don't blame you if you don't quite get this right. And let me look at, yeah, so I'm gonna say, sorry, I meant to say in forests in Canada. So let's go to the question. So in forests, and he considers it to be improved forest management.
Sure. Done. It's perfect. Like 65% choose C, but like still some students choose B, like 70%. 17, yeah.
Yeah, so Drever, prioritizes number one, improved forest management, number two, avoided forest conversion, and three, restoration, and four, urban canopy cover. That's what Drever says, and that's what this question says. In my opinion, A should be the top priority, and let me tell you why. I'm gonna, over these next few slides, will tell you why. Okay, so, and I have a question here too, but this is a map that was published a few years back. It was published in 2022, and it's a carbon map for Canada, and it shows these colors on the map, very high carbon sinks, as the dark blue, and then the orange is very low carbon sinks. And it shows, for example, that the West Coast forests, especially the maritime forests, are the biggest carbon sinks in Canada. That helps us think about prioritizing, actions over climate change. And actually the federal government is, in a way, prioritizing the West Coast as its, as a place where we need a lot of work. And it's saying that, that when they did their calculations, which were based on models and permanent sample plots and anything that the federal government could get their hands on to estimate these estimates, that Canada has 6% holds 6% of the world's forest carbon. So Canada has a big role to play in protecting those carbon pools. Okay, now you might argue that that number might be an underestimate. I would say it is, but still, it just shows that Canada does have a big responsibility globally to look after our forests. And then on the right, it shows where the soil carbon is. So it says, okay, actually soil carbon, as we've pointed out in this class, is that most concentrated in the colder latitudes in the boreal and the tundra ecosystems. And that's because, trees and plants allocate their resources where they need it most to get at the limiting resources, which in this case are nutrients and in these cold soils. And so we have a lot of carbon storage below ground in these in boreal forests. We also have a ton of carbon storage below ground in West Coast maritime forests because they're so outrageously productive. And overall, Canada holds 20% of the world's soil carbon. And, this can help us understand what, these kind of distributions help us understand where to concentrate our efforts across the nation, but also where to concentrate our efforts within the forests that we're in. And below here, I've got this timeline, which is kind of interesting. It just shows over the last 2,000 years, how many of the forests are about 2,000 years old on the West Coast. And it just gives you an idea of when we started actually really harvesting forests in earnest, which was when we introduced the chainsaws in the 1950s, and how, the impact of mechanization has really, really affected our forests. And here is, compared to a 2,000-year rotation of a yellow cedar tree, which is about normal for a yellow cedar, and what we've put those forests on, which is the 80-year rotation, just to give you a sense of how important time is in building these carbon stores in the soil and in these forests. Yellow cedar is a maritime coastal species. It's one of the most beautiful productive species. Okay, so I've got a polling question here. Which biome has the greatest carbon concentration of carbon stocks in Canada?
Start. Uh-oh. 50% choose B, only 40% choose A.
Okay. All right. So let's go over that. Let's go back to those maps. So I'm talking about total carbon stocks. So I get where you're coming from. Total carbon stocks, if you look on the left, this is total. And you can see that the Pacific temperate rainforests on the West Coast are the most carbon rich overall. The map on the right is of the below ground carbon stocks. Okay, so most of the carbon in the tundra and the taiga and the Arctic are allocated below ground. That's correct. But overall, and maybe this was a tricky question, the biggest concentration of carbon stocks overall above and below ground is on the Pacific, in the Pacific temperate forests. Okay, tricky question, I agree. All right, so, and just to, in the boreal forest where most of the carbon is below ground, and whereas on the Pacific coast, over half is above ground. So this picture is actually from that very same paper of where they made that map, and they're illustrating how in the boreal forest, and they've got, how these carbon pools are allocated. So here, look at below ground, that's the orange part. You can see that carbon stocks at 0 to 2 meters in the soil is 71 kilograms per square meter. And above ground, it's only 4 kilograms per square meter. So that means that, 90, what is it, like 90, over 95% of carbon in the boreal forest is in the soil. Okay, so and it's because the roots are, are allocating so much energy into their mycorrhizas and into all the soil food web so they can get at the nutrients which are bound up in organic carbon that has been there for thousands of years because it's held in very, very cold soils and decomposes or is cycled extremely slowly. So large amounts of carbon are in those soil ecosystems below ground. Okay, but still, the biggest carbon pools overall concentration is in the Pacific West Coast forests because of the Pacific Ocean. It's warm, it's wet, and it leads to high productivity of the forest. It's just that only half of it is below ground. All right, now let's kind of dispel this thing about that forest conversions shouldn't be a high priority according to Drever. It should be the highest priority. And that is because um, standing forests are big sinks for CO2, and they're big storehouses for CO2. Remember, the sink is the pool of carbon that's in there, and sequestration is the amount of CO2 being sucked in by those forests. Standing forests have got the biggest pools or sink strength compared to all other forests. Whereas a clear-cut forest is not taking in CO2, it's actually emitting CO2. And that's because you don't have, you only have little trees now growing there if they were planted. It takes at least 30 years on average for a Canadian forest to be a bigger sink for CO2 as these little trees grow up than a source. For the first 30 years, they're just emitting CO2. So think about it. We got to solve this problem by 2030, right? That's what the IPCC is saying. We got to get on this by 2030. If it takes 30 years for a clear cut to even get to net zero for its emissions, then, it tells us we should not be creating these clear cut forests if we're going to solve climate change in this period of time that we have to act. So by the time they're 30 years old, this young regrowing forest is drawing down CO2 again. It is a net sink, but it's a small sink because, the trees have to get to be a mature age, which in some cases can take hundreds of years in order to become the big sinks for CO2. It takes a long time for a little tree to become a big tree and to absorb all that CO2. Also, when you clear cut these forests, there's a lot of decomposition of the forest soil carbon that then is also emitted, and we need to draw back down all of that CO2 as well. So I hope that this dispels for you then that the standing forest is the biggest sink and it also stores the most CO2, much more than a clear-cut forest. I'll show you some figures a little bit later to show how much of that difference it is. But suffices to say that a clear-cut forest, just on the act of clear cutting alone, just within the first year, of taking away the trees and then accelerating decomposition of the forest floor and organic matter, that the forest loses up to 70% of its carbon dioxide, of its carbon pools, just by the act of clear cutting. Okay, so how does this add up at the global or at the national level? So this is an article that was actually written by Barry Saxifrage. You can see the citation down here below. And he goes through, this was back in 2021 when he wrote this. At what point Canada became, switched from being a big sink for carbon dioxide because of its vast forests to becoming a net source of carbon dioxide, which is due to the fact that we've been clear cutting our forests, converting forests to other land uses, and also we have accelerated wildfire. And you can see in 2002 is when Canada switched from being a carbon sink to a carbon source due to all of these activities. And this, we don't want this to happen. We need Canada to continue to become a sink again. We need to do everything we can to return it to sink status. But right now we are an increasing source due to land use change, forest fires, and conversion to things like oil and gas. Okay, what year? It's 2002.
Start. It's perfect.
Okay, good. I'm going to go a couple minutes longer and then we'll have a break. Okay, so just again, this is basically saying the same thing. In 2002, um, forests were a big carbon sink, absorbing 160 megatons of carbon dioxide a year, but that declined and declined very rapidly through the 1990s and 2000s due to forest harvesting, wildfires, and so on, to becoming a net source. So that's the red, is becoming a source. So this is kind of the flip side of looking at what I just showed you previously. And we really need to regain this entire sink strength in order to mitigate climate change in Canada. Okay. No, some people will argue that, well, when we harvest forests, we can put them into long-term storage products, and we do, but only a certain portion. So let's look at this figure then. This is just looking at sinks and sources again. So a sink pulling CO2 from the atmosphere, storing it in forests, a source, the losses, CO2 added back to the atmosphere, to the air. And it's just saying, okay, before in the 1990s, on average, we were drawing down 165 megatons of carbon per year. And 145 of that was being, in comparison, was being stored in harvested wood products, some of it in short-term wood products, but on average, overall, the forests were a sink. By the 2000s, we were still, the forests were still, early 2000s, still a bit of a sink, but we were starting to emit more from these harvested wood products. So we're doing over harvesting, basically, converting them to things like pulp and paper, short-term products, and starting to emit more from the wood products than we're actually storing in long-term products. So just think about this. On average, long-term forest products have only about, what is it? It's about a quarter of all forest products end up in long-term wood products. And on average, the half-life of those wood products, which includes things like furniture and flooring and houses, on average, they only last, their half-life is 25 years. And so, whereas a tree will live to 100, if not thousands of years. And so they're not comparable in terms of their longevity, but that is often said, oh, well, we'll put them in long-term storage products. For one, they don't last long, and we also are only putting a small portion into these long-term products. And then these other, lines, 2010, is just showing how much contribution the forest versus the harvested wood products are making towards that CO2 emission. Okay. And just so this will be the last slide I show until we take a break, is that forests are huge emitters. We're as big as oil and gas. And actually, when you add in forest fires over the last few years, we're even bigger than oil and gas. Okay, so that means we have a lot to do in forests. And I'm going to leave you with this. This figure just shows that, here's the emissions. What's going into the atmosphere is the red line. It's going up and up and up, especially going up because of fire. But Canada doesn't actually even report this, or at least it hasn't until last year, because it's always assumed that Canada was still a sink and that the sink strength buffered whatever emissions that we made from forests. And there was a lot of pressure put on the Canadian government to be honest with this, because unless we know the truth about what we're emitting from forests, we don't actually act on it. And so it was from pressure from different environmental or non-governmental organizations that said, you need to start counting this properly and stop hiding our heads in the sand so that we can actually be truthful to the international panels and be truthful to ourselves. Okay, so the reason is because it assumed that the forests were buffering against CO2 losses. So this is the polling question. Why has Canada not reported carbon emissions from managed forests?
Start. It's perfect.
Okay, good. All right, let's take a little break and come back in a couple minutes. I'll see you at 4 minutes after 12. Thanks. Hi, everybody. Sorry about the short break. Anyway, so this next figure, I'm going to keep going here, just shows how on the left, just to put in perspective, how Canada is doing relative to other countries in terms of how what our percentage change compared to the G7 nations since 1990. And Canada is at the top of, that we're adding more than we're taking down. Um, and I would argue is, we are a resource dependent country. And we also have a very flammable forest, not not entirely because of our management practices, just because of where Canada is located as a northern latitude, and we have this polar high latitude amplification of climate change up here naturally. But we also, we haven't been heading in the right direction. And I would argue that it's because we haven't really fully accepted that, that we're not doing good practices that are mitigating climate change, not yet. And we need to change that. Other countries are doing it. We can do it too, even though because of where we're located, it could be harder. But look at Japan. Japan is a northern latitude country too, and it's sequestering more than it's emitting, whereas we've gone in the opposite direction. So we need to get serious about this. The second figure, which looks like a big rock, and it just shows what we've emitted and then what the remaining carbon stocks are in Canada. And it's meant to say, we really need to keep this carbon in the ground. We need to, first of all, we need to reduce this little white area and sequester it back down through good forest practices and restoration. But you also need to keep the rest of it standing. And if we don't, it could be a huge carbon bomb, if you will, if we don't get it right here. So Canada has a big responsibility to keeping carbon in the ground and getting more of it in the ground. So how do we do this? And I'm going to go back to this experiment that I've been talking about for quite a while, or at various parts through the course, called the Mother Tree Project. And I'm going to give you some of our results. And it points to, the forest management side of things. And then I'm going to go and talk about restoration techniques that we're trying. So to address two of the things. So first of all, not converting forests to clear cuts is absolutely number one. And that's a political decision, and people need to get involved in politics to make sure our government doesn't go further down that road. And then, figuring out how to better manage our forests rather than clear cutting, finding alternatives that keep carbon in the ground. And then how do we restore the damaged forests? And the red dots are locations of our Mother Tree project along a climate gradient where we have hot, dry sites in the lower latitudes near the Alberta border, which are hot and dry, all the way up to a northern site which is cold and wet with lots of snow, and all kinds of climates in between that can help us understand, as a proxy for climate change, how these practices ought to vary with a drying and warming climate. The yellow along the west coast are looking at how do we restore restoration experiments up the coast in a similar climate gradient. What do we do to restore the forests that have been converted to plantations? Okay, let me talk to you about that. And I just want to point out that all of this work is done by students, basically. We have lots of professors involved and lots of students. And I know many of you have expressed interest in doing some of this work, and we haven't been able to, expand our work because we're limited by funding to everybody who wants to do the work. But it doesn't mean that you can't start your own programs. We're doing research, but research is just like getting at innovative ways to do things. We actually also have to do the work. So there's enormous potential for work on the land by everybody in order to solve these problems. So anyway, these are all graduate students. They're all in different graduate degrees right now. They were undergrads when they started. They're devoted to doing this kind of work. And I just wanted to show this, the kind of work that we do in counting carbon, and just to dispel what is carbon and how is it, it's not a magical thing that you do in order to count it. So this is getting at that thing about truth, right? Truth of how much carbon is in forests and how much are we losing when we do forest practices, and how much can we increase or sequester and store in secure pools when we do good forest management. And the way we do this is we measure trees. We measure what's lying on the ground, coarse woody debris, what's on the forest floor. It's all very intensive measurements. So measuring trees, going back up to this first photo, we measure the height of trees, the diameter of trees, their ages, and then we use these equations that have been developed to convert the size of a tree to its biomass or its dry weight per cubic meter. And then about 50% of that biomass we know is in carbon itself, the actual carbon, in a sugar is 50% is carbon. And so then we can get an exact number in a forest of how much carbon is in the trees. Just like in the slash, see, there's a whole bunch of slash or downed wood. We measure all of that and we have equations to figure out how much carbon is in this downed wood. We measure how much is in all the little plants and the shrubs as well. We measure what's in the soil by collecting samples. We collect samples by digging down into the forest floor and then taking some of that forest floor away, and then we dry it and we use this mass spectrometer to measure the carbon concentration in that area, that volume of forest floor, and therefore we know how much carbon is in the forest floor. We dig down into the mineral soil and we do the same thing. We go to different depths in the mineral soil all the way down to a meter, and we extract samples, and we know the volume and the mass of that volume. It's called bulk density. We figure out the carbon concentration by running the samples through mass spectrometers, and then we calculate the weight of carbon in that soil. We do this by hauling a lot of samples out of the forest and bringing it to the lab, and Jeff is very much involved in this, in running and weighing these samples and running them, drying them, and getting them ready to send off to the lab. So it's not rocket science, but it's all very doable, and you can do it. We do it, and so after we, estimate how much is in the forest before we do anything, then we know what the pools are of an uncut forest, of a primary forest, of an old growth forest. And in our mother tree experiment, which covers all of these different sites across this climate gradient, we have applied different harvesting practices or regeneration cutting methods. We compare an uncut forest. So this is our control forest up in our northern John Prince Research Forest. It's about 150 years old. It was, it originated from a wildfire back in the 1850s. And we measured everything in this forest, all the carbon in the trees, the shrubs, the plants, the coarse woody debris, which is on the floor, the forest floor, and in the mineral soil. And then we harvested that forest using different techniques. So one is we harvested the smaller trees and kept the bigger mother trees or the older trees. So it's essentially like thinning out the smaller trees from the forest, leaving 60% of the large trees behind. And then we harvested the forest in a different way. We left clumps of trees behind. So instead of taking out, an even and leaving an even distribution of the largest trees, we created gaps in the forest and left clumps of trees, which it turns out to be quite interesting because leaving clumps of trees actually helps, the trees can help protect each other from wind or fire or so on. So we found this to be actually a really good treatment. And then we planted trees in between. And then we compared it to another treatment where we left only 10% of the trees behind that are distributed across the forest. This is the seed tree method. And then we compared that to clear cutting where everything is taken. And so I'm going to show you some of the results of that. And it helps us understand what practices are best for forest management. So thinking about that forest management piece. So the first thing is, and I think I've shown you this before, it shows that the amount of carbon, the total carbon stock, varies across our climate gradient. So in our cold, wet sites, which are in the north, We have up to 600 megatons of megagrams of carbon per hectare. In the dry hot sites, we have only 250 megagrams per hectare. And so, coastal, again, this is confirming what Drever et al. Found out when they mapped the carbon pools. Or no, actually it was the map where I showed that the carbon pools were strongest on the coast. We found the same thing. The coastal forests have the biggest carbon stocks of all the forests, and the dry hot forests have much less. Okay, that's a good finding. And that 50% of that carbon is in the trees and the woody debris, which is all that you see above ground, and 50% is in the forest floor, the roots, and the mineral soil. So half of it is below ground in these temperate forests. Okay, so just again to show that this confirms what that earlier map showed. This, I think, is the Soth et al. Paper, and it showed most of the carbon pools in Canada are on the West Coast. We confirm that with our studies. And I think I've shown you this as well, but I'm going to bring it back home again, is that these carbon stocks are correlated with tree species richness. Yes, they're correlated with climate as well. But in these more productive climates, the wetter climates, we have more tree species richness, more biodiversity. And this is important because in forest management, we tend to reduce tree species diversity from, if you look at this figure, well, it can easily go from 6 to 1 by cutting the forest and replanting one species. And forestry does this all the time. So that reduces the potential of the forest to draw down CO2, because a diverse forest, as you see on the figure on the right, has got many canopy layers above ground and many root layers below ground, and that enables full capture of resources and greater photosynthesis. This little figure down below that says total ecosystem carbon tree species richness, I put this dotted line to show that below 3 species per hectare in general, we're flattening out our ability to capture carbon. So, and that's where in forest management, we're always down here to the 1 or 2 and maybe 3 species at the most. But if you're getting at least 3 species coming back of trees, then the potential is so much greater. So why do carbon stocks increase with tree species richness? It's because of their niche complementarity.
Start. It's perfect.
Okay, good, excellent. Okay, so when we do logging though, these niches they get compressed because we're losing species. When you have fewer species of trees and all other plants, you have reduced ability to photosynthesize and then redistribute that carbon through the ecosystem. So let's look at what happens in the Mother Tree project, where we compared clear cutting. Again, let's say, look at this clear cutting with uncut controls, 30% retention. You see the clumps of trees, seed tree, and 60% retention where we left most of the canopy, but thin from below. What happened to the tree species? And so I've divided these into functional groups of trees, shrubs, herbs, and bryoids, which are mosses and lichens. And you can see that the tree species goes way down because in a clear cut, we just restore 1 or 2 species compared to the, in this case, it would have been about 5 or 7 species that were there in advance. The shrub diversity and richness and the herb diversity actually doesn't change. I mean, the composition changes. We get different plants coming back, but overall, you have a lot of these plants growing back in all of the treatments. But another most important finding is that the bryoids, the mosses and the lichens on the forest floor, just get obliterated by clear cutting. And those mosses and lichens are what hold the soil down, and they do all kinds of functions. They have all kinds of food webs associated with them that do many things for the forest. So the plant group most affected by forest harvesting are the bryoids, which includes the mosses and lichens. So that's polling question number 8.
Start. Done. That's perfect.
Okay, good. I can see that our time is up. So I'll continue this when I see you next. But on Wednesday, we actually have another guest lecture. Dr. Gary Merkel. He is a Tahltan. He's from the Tahltan Nation, so he's an indigenous forester. He's going to talk about indigenous forestry stewardship. And I will note also that he was on the old growth strategic review when British Columbia was talking about how much old growth is left and what do we need to do. So he's super interesting. I'm looking forward to his lecture on Wednesday. And I will see you then. And then I'll see you again the following Monday. So thank you so much and have a great afternoon.